This is Access Ann Arbor. Hi, we're here with Laurel Federbush, my friend, who wrote this book called Flat Earth Meets Tesla, a primer on paired inverted worlds cosmology. And I was really surprised that Laurel wrote this book because I think of her as a harp player. And how did harp playing kind of lead to science?
I don't know. I mean, a lot of people, I'll be upfront about, would say this is whatever crackpot science or pseudoscience. It's whatever. It's definitely not mainstream science, but I guess the harp is a weird instrument. I like unusual instruments and unusual ideas too, and just speculation, mythology, just things that make you kind of wonder about things, and I think that's related to music. Music is mysterious. And
yeah, and it's also complex.
Okay.
Isn't it?
Yeah.
Music's some of the works that you do are very complex.
Oh, yeah.
And a lot of times, do you find yourself having to simplify it down? Or?
Yeah, actually, that's interesting. I often have to simplify, like my harp parts. Sometimes orchestras give me parts that are too difficult and too many notes, not written. Either they're just not written well for the harp, or even if maybe some harpists play it, maybe I find it awkward, so I have to either simplify it or adapt it. And so simplifying is, and I think I kind of like to simplify things in general. Like my brain can only focus on, few things at a time, like maybe one or two things at a time sometimes, and sometimes if things are just overly big and complicated, like the plot of a movie, I think this just has too much stuff going on. It would be better if it were simpler. And
yeah.
So I guess I'm kind of a minimalist in that way.
Well, yeah, I think you are. When I was reading this, it seemed very, very the ideas are extremely complicated, but there's an elegance. And a simple elegance to what you've done here. These are three basic. Although the ideas are very complex, this is a very small book, and it's got pretty big writing. But she seems to have been able to take these ideas, and it's all complete. It has a lot of bibliography in the back that you can do more research, but the ideas come across. And that's what we want to talk about a little bit here, these ideas, because we could probably talk for 2 hours on this. I mean, there's a lot here. Basically, you're talking about a completely different idea to what we've all been brought up with. Right. The idea that the Earth is the way we've been taught it is. And Laurel has some very interesting ideas about what the Earth actually is. Would you care to elaborate a little bit?
Yeah, let's say some of the ideas aren't okay. Start off. The idea that the Earth is flat. That's not my original idea. That goes back thousands of years. I would say thousands of years. Some people think that the Earth and the universe are millions or billions of years old, but I'm saying. At least thousands of years. We don't have evidence that it's older than that. And it's flat, and that's the way we observe it to be. And I'm not the one who thought of that. But once you believe that the Earth is flat, you would want to explain, well, how does the universe work? What are the scientific principles? What's the sun? What's the moon? And this was my attempt at explaining what a flat Earth cosmos would look like. And one of the things in the modern age, there's the YouTube. You can get access to all kinds of unusual ideas through YouTube videos. And this is how I got into all this. I started watching
I was wondering.
Sort of alternative astronomy ideas, like a lot of people are into Planet X or Planet Nibiru and just things like that. I guess I have a conspiracy streak, so the idea of yeah, and that's got me into some, there are all kinds of weird conspiracy ideas, but this one, I just started looking into alternative cosmology ideas just for fun, and some of them started to make you wonder, well, is this true, is this not true? And one of them I came across some guy saying the Earth isn't spinning and it's not even moving. But it wasn't like some sensationalist video. It was a guy with some physics training, and he was making some real physics arguments why there's no evidence that the Earth is moving. So I watched it, and he was very serious and said gases don't stick to, like if you're smoking a cigarette and you move, the cigarette smoke doesn't follow you. Like there's no reason why the gas would stick to a moving object. So that was one of his arguments. The other was that the mass of objects would be significantly different at the equator from at the poles, and
it's interesting. It's interesting to think about.
Yeah, right.
And kind of get into their world. It's like kind of trippy.
Yeah.
So you're kind of attracted to trippy things.
Just things that sort of turn everything you thought.
Yeah, it's fun, isn't it, to kind of expand your mind and think, what if?
Right. Yeah.
And I just want to be clear. You're not much of a conspiracist. You are attracted
I sort
to
of
that.
am.
Are you really?
In some ways. I guess years ago I got really into some conspiracy theory about the government tracking people, and I kept doing research to try to prove that, and eventually I sort of came to the conclusion that the person who I was relying on for information was more likely that things weren't actually happening exactly the way she said they were, even though some of the information I came up with was kind of interesting. And I think people who get too caught up in conspiracy theories, like me at times, I don't think it's really good for your psyche to, I mean, I'm sure that there are powerful people in government conspiring to do all kinds of things and not being honest, but we basically have to just live our lives in spite of all of that. There's, if there's nothing you can do about it, you shouldn't spend all of your energy trying to.
Well, you can blow the whistle.
Right. Yeah.
As much as you can. And I really like what you're doing is exposing these ideas, because and really what you've done too. We haven't really got into what it is you're actually doing, but maybe we can talk about that later.
Okay.
We probably should talk about actually what it is that you're proposing here.
Okay. So anyway, there are all kinds of YouTube videos. Like anyway, once I watched this guy's video, he wasn't into the flat Earth idea, but he was a geocentrist. That means the idea that the Earth is at the center of the universe. So there are a lot of people who are geocentrists, but they don't believe the Earth is flat. They just believe that the Earth is round and it's at the center of the universe. And I think there's some new movie out called The Principle. I don't know if it's in theaters or on video or what, but this guy, Robert Sungenis, made this movie with evidence that the Earth is at the center of the universe. And but anyway, from geocentricity, I got into other ideas in the YouTube videos. There's this one guy who had this interesting theory that the Earth is concave, like that it's round, but we're actually inside it, or the whole cosmos is inside of it, and the land or the Earth we're on sort of moves up like that. It's sort of like we're on the inside of a ball, and the sun and the stars and everything would be at the center. And so I got kind of into his ideas for a while, and but I guess I didn't stick with that. The flat Earth thing just seemed to make more sense. There are a whole lot of good videos that would give arguments for why the Earth why they think the Earth is flat. For one thing, you can see a lot farther than you should be able to see if the Earth were sloping away from you. It would be sloping away like 6 inches every mile, and the Earth actually, the theory of the globe is that the Earth has like a 8,000-mile diameter and 25,000-mile circumference. So it's not like an infinitely big ball. You know, it's at some level, you know, we should be able to see the curve of the Earth. You know, but there's actually, you know, if you climb the highest mountain, you go up in an airplane, there's no place from which we see any evidence that, you know, we can't see the curve of the Earth. The only evidence for the globe theory is from like NASA pictures that we see on TV. And, you know, if the only evidence is something on our television screen, I think that's kind of suspect. You know, like, so how did the people come up with the idea before NASA? Like, oh, that was something that was kind of, I did some research into where did the idea of the round Earth came from. And it's not just, it's part of a bigger thing. It's not just that the Earth is round. It's part of a whole thought system that actually goes back thousands of years. It's the idea that the Earth, it goes back to ancient sun worship in India and Persia. The idea that there's a sun, that the sun was their main god, and the idea that the sun is at the center. And they had some versions of ancient Indian mysticism had this idea that the sun that we see is actually a reflection of another sun, like the sun, greater sun being God. And we see, and the sun we see is a reflection of God. And so
yeah, sun
like
worship, and that's like one of the earliest religions
Yes.
that came out. And it kind of makes you wonder, well, just because we're more advanced according to what?
Right.
You know, maybe they knew.
Yeah.
Maybe they really got it, you know, and so, in some ways, you know, and then as you go along, you know, it's like telephone. You know, the information sort of gets,
Right.
You know, people have different agendas, and then next thing you know, we've got this globe, and it's,
Yeah.
you know, spinning, and, you know, it's just really interesting to see how information becomes sort of the thing.
Yeah.
So anyway, this is a picture of kind of an idea of what you're talking about. Two flat Earths together with people underneath that we don't even know about, we'll never see, or maybe someday we will.
Yeah. Okay. Yeah. My idea is that yeah, the Earth is flat, and yeah, there are these two flat Earths paired together, and we have a sun and a moon, and they have a sun and a moon. They're upside down from our point of view, and yeah, so that's.
And there's something talking. This sun talks to this moon, as far as like a wave, or what?
Yeah.
What holds these things together? Is this the right picture?
Okay.
Or maybe we should use a different picture for that one.
Okay, yeah, so this sun is a transmitter. It transmits scalar waves to this moon. This moon is a receiver. And this sun is also a transmitter. It transmits scalar waves to that moon.
Scalar, and that's where Tesla comes in.
Right.
He's the one who invented or who discovered scalar waves.
Yeah, it's a theoretical thing, and you know, again, this is sort of fringe science. Mainstream science doesn't go along with a lot of Tesla's ideas, but a lot of people think he was, you know, really brilliant and really did have some great ideas about free energy, among other things. So
Yeah, well, they named a car after him. Can't be that
oh
bad.
yeah, it must be.
But what I'm a very technical person,
Okay.
and I'm just having trouble here with the two. Can you explain to me, why is the sun drawn over on the other side?
I think I actually brought the wrong picture.
Oh, okay.
I think
Okay, but that's kind of the idea, is that there's
Yeah.
people on this side and people on
Yeah.
that side. Okay, because I'm just
Right.
trying to wrap my mind around
Okay,
this.
yeah.
Very complicated
Oh, and
stuff here.
the moon has holes in it. Like, The
Yeah.
holes
Where'd they come
enable
from?
it to receive the scalar waves.
Was
like
that-
our telephone receiver has, you know, you're talking to a telephone, there are
Kinda
holes
looks like
in
a
it.
telephone
Yeah,
receiver.
exactly. Yeah. So
Was that just accidental? The craters are there. The holes that are in the moon is from craters, right?
well, this is the thing. The scientific ideas we're taught is sort of that the world and the universe came to existence kind of by accident, just by happenstance, and it just worked out beautifully, but that's just kind of an accident. But I don't think there's any reason to believe that. I'm not actually like a biblical creationist. I don't believe every word of the Bible is true. I just happen to think that the Bible is closer to reality on these scientific matters than modern science is. For one thing, it's, these are kind of simpler ideas. I tend to think that, well, there's a principle, was it Occam's razor, that the simpler an idea is, the more likely it is to be true. I mean, again, that's a simplistic version of, that's however he stated it. But the Bible's, the literal Bible ideas are simpler than modern science, and there's no reason to believe that it has to be more complicated than that in a lot of instances. So, the Earth is flat, it looks flat, it behaves like it's flat, and so there's no reason to assume that it isn't flat unless someone can come up with some really good reason to believe that, and there actually isn't any good reason to believe that it's not flat. So.
Yeah. I mean, I've been talking about it for being flat. People think it's a backwards idea because they thought of it first.
But I guess I'm not sure if I quite finished what I was saying about the Earth being round. That's actually an ancient idea. So we think of the flat Earth as being like really retro, like thousands of years ago. But the idea of it being round that comes from the idea that the sun is the central god, and the Earth is just one of the many planets going around the sun, because the sun has to be at the center. That's their god, and we're just little servants of the god. So, and also it comes from ancient drug use too. I think the people who had this theory also believed that there were creatures roaming around on the sun and the moon, and I tend to think that was from drug use. And the people who wrote the ancient Indian, the Rig Veda, their ancient holy books, they were inspired in part by the drug soma, and we don't actually know what soma was, but
I hope that's
it could have been a hallucinogenic drug of some kind. So.
I hope that's not blasphemous to say it came from drugs. Maybe not.
Well, some of their
yeah, that's just what they did.
Yeah, it was, and the ancient Greeks also took drugs, and that's a documented fact. But it's I don't think that's necessarily the entire inspiration. Just that was one of the things that they did. And and I think it was a holy book. There's a lot to be gained from those ancient texts. It's holy the way that the Bible's holy too. So it's just one of the ancient texts. But people tend not to look to the Bible for great science, and if they're not willing to look to the Bible for science, I don't see why they should be looking to ancient Indian religious texts for science, which is
good
basically
point. Good point.
And it's not just I guess ancient Persia was at the time. They had that. Zoroastrianism was a big religion that was sun worship also, or it had a sun worshipping element to it, and so those were the big ideas. That's sort of where idea came from, of the Earth being something that had to revolve around the sun.
Yes. Well, I just think these ideas are fascinating.
Okay. Oh yeah. I was also going to mention the idea that things are just accidental. I think that the sun and the moons, they have a function. The sun has a specific function, and the moon has a specific function. And there's no reason to assume that they're just random rocks or balls of gas or things like that. And that, it's like your body. Your body has a heart and a liver, and each one of those performs a specific function. And I think it's the same with the sun and the moon. So, okay. Anyway, so the sun is a transmitter. The two suns are transmitters. The two moons are receivers, and the two flat Earths are receivers. Or I'm sorry, they're resonators. They're resonators. So, according to this idea of how to produce scalar waves, you need a transmitter, a receiver, and a resonator. And each one of these, these are scalar waves. The scalar waveform is an idea that Tesla came up with. Scalar waves can go through any object, doesn't matter how thick, and they can go backwards and forwards in time. They're kind of seemingly magical, but they have all kinds of interesting properties. Those are called longitudinal waves, is another name for it. And I'm not a physicist, so I'll get in trouble if I try to say too much about it, but these are the, other people can look up what a scalar wave is or what a longitudinal wave is. It has it has magnitude, but it doesn't have direction. So, and it exists in the vacuum outside of the material world, but it can create energy that exists in the material world.
So you've put these ideas together really in a way that no one else has put them together before. All of these ideas. That's what I think is so brilliant. And whether or not it's true, we don't,
Right.
but I think we could
Yeah, I'm
dive
open to the idea that
into
might not
this.
be true, but this is my attempt to explain some of
Yes.
the things.
And
we see
how
on
else to find out if it's true or not?
Right.
By putting it out there.
Right, yeah.
And,
And that's one thing, like I was saying, the flat Earth idea, that's not at all my original idea, but the idea of, well, one of the things people say, well, if the Earth is flat, what's underneath it? So this is my idea of what's underneath it. And I think no one else, as far as I know, has come up with the idea of the sun transmitting to a moon on the other side of the Earth, and and them having a sun that transmits to our moon. That's totally
Where
my
did you come
original
up with
idea.
that?
Well,
Did you just
looking
wake
up
up
the
one day?
idea of the, well, again, I like unusual ideas, and I guess all of my looking into some of these alternate science things, I came to Tesla's theories, and they just seem to fit together so beautifully as far as I was concerned.
Yeah.
So, okay, this is the next picture. So anyway, there are stars too, and my idea of what the stars are, these are stationary waves, like the scalar waves. It forms like a sort of just a standing wave like that, and they cross each other. And according to the Tesla's theories, when they cross, they would create sort of an explosion, and it would lead to a shell, like a hard, impenetrable shell, like a big bubble on the outside.
Is that what's called a Tesla shield?
Yeah, I don't think Tesla himself called it that, but was it Tom Bearden? He's another guy who was into the scalar waves. There are a lot of people who are sort of disciples of Tesla, or they took Tesla's ideas further or studied them more. And,
He's military, right?
Yeah. Yeah, so that's right, yeah. But anyway, so my idea of what the stars are is that they're luminous points on these bubbles. So they're sort of like concentric bubbles that would move probably independently of each other. So when, the stars are moving, like those are points of light on these bubbles.
They're not
that are
big.
formed by no,
They're not gaseous things that have other planets running around. That's
I mean, they're just small. Like all of this is like unbelievably small like we're used to thinking of this vast, enormous universe.
yeah.
And that's another thing that comes to us from the ancient Indian the Indians pioneered math. So like they were into advanced mathematics. I think ancient Babylon had some advanced geometry too. That Pythagoras, people say he stole a lot of his theorems from ancient Babylon. But anyway, ancient Indian mathematicians go back way before, maybe earlier than almost anyone else anyway, or maybe than anyone else. But I think because they were so advanced in their math, they loved these really huge numbers. So they came up with the idea of billions and trillions, or they talked about the universe and the Earth being millions or billions or trillions of years old. They talked about that way back then, and I think that's just because they loved numbers so much. And they also thought that the Indian culture, the Indian civilization, went back millions of years. So I don't think even modern scientists wouldn't agree with them about that. But but that's the origin of our ideas about the universe, and also a lot of ideas about evolution. That's derived from their ideas about reincarnation, and like Pythagoras, who we get a lot of our scientific ideas from. He was also into reincarnation, and I think he reportedly, like in the ancient world, there were people traveled, and there were people traveled from the east through Turkey, and the ancient Greek philosophers hooked up with them, or the ancient Greek philosophers might have traveled. So anyway, these ideas moved to ancient Greece. So the Greeks were influenced by the ideas from India and Persia, and so that's where, like, modern science was derived from things that weren't scientific. So that's one thing. I don't think people assume that because scientists have tended to believe something that it must be scientific, but that's not true. Like science was, I'm talking about the idea of evolution, science evolved from something else, but what it evolved from was actually not science. It evolved from this some of these ancient mystical ideas, and so they're good. We developed the scientific method, which is a very wonderful thing that can help us understand our universe, but scientists often have not looked at the origins of some of their ideas to see where they came from. So they just, along with the good things about science, they sort of adopted some things. They haven't examined all of their own ideas critically enough, I think.
Yeah. Well, that's pretty good point, you know, that I think it's a good point. Now, so you've come up with that idea of the scalar waves coming together.
Yeah, or I just want to say, yeah, my book's available at the library. In case
Okay.
anyone
Yeah,
wants
you
to
can
look
always,
it up.
if you're interested in this, if this has piqued your interest,
Right.
it's at the Arbor Library. The book. It's very quick read, but there's a lot to it, and there's a lot of. She didn't just, you know, she's not just coming up with this. There's a lot of different sightings,
Right, yes, you can check out
references.
things
She's
yourself,
got it
yeah.
all written down, all where she came up with these ideas and put them together so eloquently.
Right. Yeah, the book doesn't have pictures because it would have
No.
been more expensive for me.
Right, but
to
it has a really
publish
nice
it
cover. It's
and-
very
right, yeah.
attractive.
Well, thank you. Anyway.
And I think it's important to question, you know, just because people have always said something.
Oh, just another thing I was going to say about science. Our astronomy was actually interchangeable with astrology for most of history. So, like, you think of those as totally different now, but throughout most of history, science, or astrology and astronomy were actually the same thing. And it's only recently that they diverged. So, people like Sir Isaac Newton were into all kinds of things like alchemy and astrology that now we would not consider science. So if we're willing to dispute some of their ideas about those things, I think we should be willing to also dispute their ideas about the cosmos. So,
Yeah, we don't know.
Right.
I mean, it's worth delving into. I mean,
Right.
these ideas are really, really good. Gosh, I don't know what else. Have we shown all of the
Yeah.
pictures? Okay, so they've seen all of that since we didn't have them in the book. So.
right, yeah. So, yeah, so anyway, just be willing to, just being willing to question science. And we said, yeah, science is actually, a lot of the ideas that we take unquestioningly, it's just because, you know, maybe we've seen them on our television, or you know, someone with a degree from an important university
Right.
comes to us with a particular idea.
And we're such visual people.
Right,
When
yeah.
we see it, it's like, oh, that's the way it is.
Right.
So it's very interesting. I could actually talk more about this, but I don't want to get into too much because we're ready to wrap up here. But yeah, I just want to.
Thank you so much, Anna. I really
Oh, you're
appreciate
welcome.
you
No,
coming.
this is a good stuff to get out there, and and
I just think it's fun to think about. That's
yeah. And
So like
there's
even if even if you think this is whatever, think of it as an entertaining science fiction idea, if nothing else.
But I think I think you're onto something, Laurel.
Okay.
I really
think
do.
so.
Okay, well, thank you so much. I think we're done here, but it's been a really good little talk here.
Okay. Thank
So,
you.
I think